Hello friends, thank you for watching this video. I am Mohamad and I will be giving you today an introduction about JWT. So, what are we going to be covering today? First, we're going to discuss what is JWT, when should we use it, what's the difference between JWT and a session ID, and then we're going to explore the JWT structure, and then the signature that makes it secure. So, what is JWT? JWT is an open standard. First of all, JWT stands for JSON Web Token. It's an open standard that defines a compact and self-contained way to securely transmit information between parties as a JSON object. In simple terms, it's an encrypted JSON, and it's an encrypted string in JSON format that contains sensitive information that will allow us to verify the sender between different services. And as we can see here, a sample of a JWT token that's being generated by a service. We're going to be exploring how this works, and then we're going to be exploring how it's being created as well. When should we use JWT? There are two main usages for JWT. First, we're going to use it for authorization, and then for secure information exchange. So, when is it used for authorization? Authorization is the most common scenario to use JWT. JWT is used for authorization, but it's not used for authentication. With authentication, we can actually generate the JWT. So, authentication means that we are sending the username and a password for the server in order for them to verify it. Once it's verified and the user is able to log in, we are generating a JWT for authentication. And authentication means that with every request that we do after the user has logged in, we are able to authenticate that this user has access to the service and they are able to get the information back. When it comes to information exchange, JWT is a good way, it's a good secure way to transmit information between different parties. Because JWT can be signed, we can use the same secret key in order for us to encrypt and decrypt those values and for us to verify the authentication and the validity of the token that we are sending. So now let's discuss what's the difference between JWT and Session ID approach. We're gonna start by the Session ID, and then we're gonna be discussing the JWT based approach. So within a session based approach, we have a client here who's gonna be sending the username and a password for the web server. So once the web server verifies the authenticity of the username and password and allow the user to log in, the web server basically is gonna be generating a Session ID. And this Session ID is gonna be saved within the server memory. And after that, the server is going to send back to the user the session ID, where it can be saved in a secure cookie or in some kind of a local cache inside the client browser. And then after that, every request that the client has to do, they need to attach the session ID with it. And for example, let's now think of that the client want to view their own profile. The client has to send with the request their session ID. And once that request reaches the server, the first thing the server is going to do is going to check the session ID if it exists with its own memory. And if the session ID exists inside its own memory, it's going to then query the database to find that user and make sure he has all of the right authorization to view the profile. And then after that, it's going to send back the response to the user to view the request. But when it comes to a JWT approach, it's a bit different. So the client first sent to the web server the username and password, and then the password will actually gonna be verifying that username and pass. Once the credentials are verified, the server is gonna be generating a JWT token. So the first difference we can see here that this JWT token is not saved anywhere. It's just generated and it's sent back to the client. So after it has been generated, and let's say for now it's generated in a secure, we're going to be discussing in later detail how it's being generated and what information it contains. But for now, let's say this JWT is generated and it contains all of the information, all of the secure information, and it's going to be sent back to the client. So the client can save it in a secure cookie, it can save it on local storage, different secure implementation, and then with every request that's gonna go to the server. For example, let's say the user again wants to view their profile, we'll have to attach the JWT token. And the way we attach it here is via the header. We're gonna be discussing this as well within the later part of this video. So once we send that JWT token back to the server basically is gonna do some the server is basically going to be doing some hashing algorithm to make sure that, to verify that the actual token that's being sent is valid, and then it's going to be able to extract information from it to check if the user has access to this page, and based on that we're going to be sending back the response. So we can see here that the server does not check the memory, the server does not query the database for information. All of the information that the server needs is already included within the JWT token that it has received. So it's a self-contained unit. So next, let's discuss this in a bit bigger scales. So here we have a web application with a single server, and we can see basically both of these servers act the same. We have a JWT based server where all of the tokens is being sent back to the server, and then the response is being sent back to the client. Similarly here we have a session based where the client also send the request for the server, the sessions are being saved in the memory, and then these are being sent back to the client. So we can see it's a very simple approach when it comes to a single server or a small application. There's not much difference between them. The main difference, it comes when we expand this architecture. And let's say right now our application grew, and instead of having one server, we're gonna have, for example, 5 servers, and these 5 servers already gonna be sharing the load of the application. So basically, let's break down this into small pieces, and we can see where the complexity lies when it comes to implementing a session-based web apps with multiple servers. So the first thing we can see is we have one server here and another server there. And those server here, for example, server 1 is responsible for session 1, 2, 7, and 8, and where server 2 is responsible for 3, 4, 5, 7. So let's say, for example, my client wants to do some kind of request for my web server. So basically these two web servers are sharing the same application. And the reason that we have multiple web servers is because we have a lot of traffic and we want to share that traffic across different servers. So let's say the first client is done a request, and this request has flown all the way up to the load balancer. And then the load balancer decides, I need to send this to server 2 because server 1 has a lot of traffic coming through it. So the load balancer decides that it's gonna route the traffic to the second server. But we can see here that we have our first problems. And then the first problem is that because the first server has authenticated that user and the session ID exists only within the first server, the second server does not know that this user has been authorized, and does not know that the session ID that it has is a valid session ID because it doesn't contain it within the memory. So there's going to be two options here. So the first option is to log out the user and force the user to log in again, which is not at all a good user experience. And the second one is to actually try to get the information from the cache. So it tried to figure out from the cache. And so why do we need the cache here? The cache here is basically like a shared storage for sessions between these two servers. So let's say, for example, the first client wanted to sign in, and once the load balancer for the first time it redirects to the first server, it creates a session ID. So that session ID has to be duplicated within the session cache. So that way we have session 1 here and session 1 here. Again, if, for example, client 3 wanted to log in, it will go through the load balancer. The load balancer decides it's going to have to go to the second server. The second server will create a session ID, and that session ID will gonna go to the cache as well. So now we have like a shared group of sessions between the two servers, and this usually lies between different multiple servers. So let's say we have 6 servers. This session cache is going to be shared within those 6 servers. So let's repeat the process of logging in. We said that the request came from from the client 1 to the second server, and the session ID was not found within the memory. And then the server have to go to the cache and check if it's there, and it's actually there. It's gonna come back and do all of the querying to the database to make sure that this user has the valid access to view the request that they requested, and then it's gonna send back to the user. But we can see that this is a bit of a complicated way to implement this, because first we need to make sure that always the cache is updated and it's always being synced with the different servers. Second of all, the process of first querying the data, the RAM, the memory, and then querying the session, and then querying the database, this could be a bit take a bit of time in order for it to be completed, so it's not as fast as we like to. And second of all, let's say if there's any failure on those servers and these sessions are not synchronized between the server and the cache, it's gonna be very hard to, basically it's gonna be impossible to recover any logged in sessions. And this means that any session, for example, if the first server fails and we have 4 users are already using this first server and it's not synced with the cache, these 4 users are gonna be removed directly, or their session is gonna be lost, and basically these 4 users will have to relog in again and reauthorize. And the second part is, let's say if the cache is out of sync. So let's say here we have 4 sessions, and on the other servers we have also 4 sessions, and from the first server 2 sessions has logged out and we didn't update this to the cache. The session, anyone who has that secure cookie will be able to again to log in because of missync between the server and the actual cache. So we can see that when it although it is possible to have scalability when it comes to a different different application using session-based approach, but we can see there's a lot of complexity as well that comes with it. And another reason that we want to discuss, we want to discuss here is, let's say server 2 is a completely different application. So for example, let's say the first application here is our bank application, and the second server here is our rewards application. So these are 2 completely separate applications, and this is something that happens within big enterprises and big companies. So we have completely different servers, and although they are completely interlinked with each other, they are completely different as well. So let's say have a user who's logged into the first server and they want to go from the bank application to the rewards application. Using the session-based approach, that will not work, because even though we have the session ID here, the way that this session has been formatted and saved in the session cache, it will not work with the second one because it's a completely different application. Although they are sharing the same database when it comes to users, the actual session, how it's generated, it's completely different. So for that case, this will not work. And this is one of the main benefits of having JWT tokens, which we're going to be discussing within the next slide. So now we have implementation for multiple web apps with JWT token. So let's take one flow and see what happens. So we have for the first client here, and the first client wants to authorize with the server, for example. So the request is gonna flow all the way up to the load balancer. The load balancer is gonna be deciding on which server it's gonna take based on availability, and let's say it's gonna take it to the first server. So once that request reaches the first server here, the server is gonna be authenticating the user and generating a JWT. But we can see the first difference here is there's nothing saved on the server. So the server only created that token for us and then is sent it back to the client. And now the client is responsible for us to save that token in a secure cookie and a secure local storage or anywhere that it wants or based configured. And then after that, let's say there's another request coming and it reached the load balancer, and the load balancer decide that the first server is completely busy, so it's gonna route it to the second server. Once it reached the second server, it's gonna basically just decrypt the JWT token and be able to continue with the request. So there is no session checking, there is no querying the database, all of the roles are already integrated there. So first of all, we can see that there's a lot of benefit that comes from that because it's much more quicker, it's way more sustainable. And let's say for any reason the first server has completely crashed, we don't have to worry about storing the sessions or maintaining synchronization between the server and the cache, because we're not using any of those, because these 2 servers are sharing the same kind of keys to encrypt and decrypt those JWT tokens. It's gonna be an easy flow between the first one and the second one, and there's not gonna be any checks when it comes to sessions or actually verifying that this is a key that has been generated by this server, because it doesn't really matter. as long as it match the criteria to have a valid JWT token, which we're going to be discussing later on in this video. This request is going to flow easily. So basically, this also provides a very simple infrastructure. We can see that we have removed a lot of the complexity when it comes to session checking, keeping the keeping the servers up and running. As well, it will be faster for authorization. As well, we can see that the server requirement in itself is going to be lower than the actual one with the sessions. Because if we take a look back at the session here, all of these is going to be saved in the memory. And let's say we have a server which, for example, has 32 gigs of RAM, and this RAM is going to get full. So let's say there is 100,000 users hitting those servers. This server can only handle up to 100,000 users with its amount of memory that it needs, and the amount of virtual memory that's also going to be able to utilize from the hard drive. So these two, this makes it a bit more expensive as well to maintain. But when it comes to JWT, we don't really need to worry about this, because we're not doing memory intensive stuff when it comes to authorization. All we're doing is decrypting or hashing actually, or the JWT token that we have in order for us to extract the information. So let's do a quick summary about what's the difference between JWT and a session ID. So the first of all, when it comes to JWT, nothing is saved on the server. The JWT token is created on the server, but it's stored on the client side. Where on the other hand, the session ID is created on the server and it's being saved, continuously saved on the server memory, as well it's being saved on the client side. And for every request there, it needs to be rechecked from within the memory and then rechecked from the database. While on the JWT side, all we need to do is store it on the client side and just handle that token on the server without doing any other checks. Second, where this is a similarity, both of them are encrypted and both of them are signed. There's different types of encryption that both of them implement, but we're not gonna delve into the session ID encryption, while for the JWT one, we're gonna be discussing it later in this video. Third point, tokens contain all the user information. So basically the JWT tokens that we have created, it will contain all of the required information for that user to be authorized with any request. On the other hand, the session ID only contains the ID of that session. And then once the session ID is sent back to the server needs to verify it from the memory. And then based on that, it needs to query the database in order for it to get the information. So we can see within the JWT, it's a self-contained unit with all of the information, while the session ID is just a reference of a link to the database for us to actually get the information. As well, the last point that I want to discuss here is scalability. So when it comes to JWT, scalability is a key. So as we saw before, the infrastructure is simpler. It's way much easier to handle different requests coming from different users for different servers. As well, it is much easier for us to bring up a server or remove a server without actually having to worry about losing sessions, losing load-in users. So now let's discuss a bit what is the structure of a JWT token. The JWT token consists of three parts separated by a dot. So we have the header, the payload, and the signature. So every one of these, so here we have, for example, we can see by the color coordinates. So the first one, which is red, it's the header, it's base 64 encoded. The payload is also it's here in purple, it's also in base 64 encoded, and the signature, it is also encoded. And we can see we have these dots here in order for us to make it easier to read and actually separate the information from this token. So now let's discuss what is in the JWT header. The JWT header is typically consists of two parts. The type of token, in our case, is going to be JWT, and the algorithm that is used to sign this token. So here we can see, for example, the first part, which is the red part here, consists of this small JSON. First is going to be the alg, which is going to be the algorithm. It's for example, it's going to be the HMAC or 256, and the type is going to be JWT. And just let us just remember that this JSON here is going to be base 64 encoded. The second part we're going to be discussing is the payload. So basically, the second part within the payload, it consists of three types. and these types are claims. So we have three types of claims. First, the registered claims, the public claims, and the private claims. So what are the registered claims? The registered claims are the predefined claims which are not mandatory but recommended, which contain some useful information like the expiry time, who's the issuer, what's the subject, who's the audience, and all of these types of information. So it's really good for us to input these registered claims. The second part of them is the public claims, and these public claims basically add more information for us, like the name. These are basically the custom information that we want to put. They are not sensitive information, but it's really good for us to know. Like, for example, this token represents which user, what's their ID, and if it's, for example, an admin or not, and if it's, for example, the expiry date for this and when it was generated. And the private claims are the custom claims that we create in order for us to share secure information between different parties. So for example, within a private claim, we can put some more information about like the validity of the token, for example, or we can put validity of the request, the access, additional access right that we might need for those requests. So all of these will go within the private claims. So just to do like a quick summary on this, the registered one is basically the expiration, the subject, the audience. All of these are the predefined claims that we have. It is really encouraged and recommended for us to use. The public claims are all of the additional information that we want to put, like public information like the name, some basic ID information. And the private claims at the end is basically some more of the secure information that we want to add in order for us to facilitate the communication between different services. One more thing I would like to add here is we should not put secret information inside the payload or the header unless the JWT is encrypted, because there's different tools online that would allow us to actually generate to view the JWT and analyze it. And if we put some secret information there, it can be visible for anyone who can basically revert the base64 encoding. So unless the JWT token is encrypted, it's not at all recommended to put any secret information within the payload or the header. So the next step that we're going to be discussing is the signature. So this is the last part of the JWT token, and basically the signature allows us to validate the token and that no changes has been done to it. So the way this works is, we can see from the illustration here, it takes the first two parts of the token, it encodes it. So it takes the header here, it will do a base64 encoding, then it will add a dot, and then it takes a second part, which is the payload as well. It is encodes it again, and then we have the secret, and this secret is being used for the algorithm that has been specified in the header. So for example, it could be the hatchmark or it could be the RSA, and this secret here is gonna be be used for us to actually hash the information that we have and match it with the actual third output that have came out. So for example here, let's go back. So here, for example, in the secret, it's gonna basically encode this one, the information in the header, and then it's gonna encode the information in the payload, and then the verification process, what it's gonna do, it's gonna regenerate the secret or the signature here based on the information inside the header and in the information inside the payload. And if those two hashes meet or these two hashes are equal, it means that the JWT is valid and it has not been tampered with. But in case these do not match, it means that the JWT token is not valid and it has been tampered with, and so the server will reject it. So let's go back to the slide and let us reiterate what happens. So basically, the verification process, or actually how the signature works, is once the server for the first time authenticate the user and to create the token, it will do this process. It will take the base64 of the header and the base64 of the payload, and it will add the secret to them, and then it will implement the hashing algorithm, and then it will attach it to the token and send it back to the user. So after that, when the user sends this back and the server wants to validate if that token is actually valid or not, it's gonna do the same thing. It's gonna take the header, encode it into base 64. It's gonna take the payload, encode it into base 64, and it's gonna concatenate them with the dot. And after that, it's gonna add the secret that it has, and it's gonna do then the matching. If the HMAC if the hash is that it's outputted matches the hash that has been provided with the JWT tokens, then the server in that way it can verify if the information is actually valid or not. So let's discuss a bit about the signing. So JWT can be signed two ways. It can either be signed with a secret, which is going to be the HMAC algorithm, or it can use a public and private keys using RSA. So you have you have the ability here to choose what type of encryption that you want to use in order for you to implement this functionality. Now let's jump into our web browser and see a website that will allow us to explore and familiarize ourselves more with JWT. So currently here we have a website which is called JWT.io, which is really good, and I highly encourage you to go check it out and you can experiment with it for yourself. So we can see here that we have a sample JWT token that exists, and we can see which information does it represent. So we can see it's separated into three parts. It's separated into the header, into the payload, as well as the verified signature. So we can see that in the header it contains the algorithm and the type of it, and then we can see we can see within the payload that we have all of the information that we want, and finally we have the signature here. And although this is not a secure password, but I just put it here for the information. So let's say I want to change my name from Muhammad to Mohamad Lawand. We can see automatically how the JWT token has changed in order to reflect that change in the payload data. Or let's say I want to change my ID to 1, we can also see how it changed. And if I put any other invalid password, any different password, we can see that how it's automatically changed for us. And let's see if what I can do as well is I can make it as base 64. So here it is hashed, and if I do it as base 64, actually now the three parts are base 64. So thanks a lot for watching this video. I really appreciate your time, and I already have another video which explains how to implement the JWT token inside our ASP.NET application. I will link it in the description and on the upper right hand side here. Please feel free to share any comments or any question that you might have. Have a good day.